Hey everyone, and welcome. Today, we're diving into one of C's most useful features for keeping your information organized, structures, or as you'll always hear them called, structs. If you've ever found yourself needing to bundle different kinds of data into one single neat package, then you are absolutely in the right place.
So, here's the game plan for today. We'll kick things off by figuring out what a struct actually is, and more importantly, what problem it's designed to solve. After that, we'll get into the nitty-gritty of the syntax, check out a really handy trick called typedef that makes code way more readable, and then we'll learn how to save our data so it doesn't just vanish.
Okay, so first up, why do we even need these things called structs? I think to really get it, we need to see the kind of coding headache they were invented to cure.
Right. So imagine you're building, let's say, a system for a school. You've got to track each student's ID, their name, and their GPA. The big question is, how do you make absolutely sure that one student's ID number is always tied to their name and their GPA? You can't have that stuff getting mixed up.
Well, one way you could do it is by just creating a bunch of separate variables. You've got an integer for the ID, an array of characters for the name, and a float for the GPA. But, see the problem? There's nothing here in the code itself that logically links these three things together. They're just floating around. As your program gets bigger, this gets really messy really fast.
And this, my friends, is where the struct saves the day. Just think of it like this. You're creating your very own custom data type. It's like a little container, a data package, where you can stuff all that related information and give it one single logical name. It's the perfect solution to all that data chaos.
All right, so we get the what and the why. Now let's jump in and see how we can actually use a struct in our code.
Working with structs really just boils down to a simple three-step dance. First, you define the structure itself. That's the blueprint. Second, you declare a variable using that blueprint. And third, you access all the good stuff inside it. Let's break down each step.
Step 1, making the blueprint. Here, we're creating a template, and we're calling it student. Inside those curly braces, we're just listing all the variables or members that we want to be a part of this package. So we've got our integer ID, our character array for the name, and our float for the GPA. Oh, and see that semicolon at the very end? Super important, do not forget that. Okay, now for steps 2 and 3. We declare a new variable, student1, and we tell the compiler it's a struct student type. Then, to get at the data inside, we use the dot operator. It's that simple. So, student1.id lets us get to the ID member inside student1, and we can give it a value, just like any old variable.
Now that we've got the basics down pat, let me show you a little pro tip. This is a technique that makes your code so much cleaner and easier to read.
This slide just says it all, doesn't it? Look at the left. Every single time we want a new student variable, we have to type struct student. But look at the right. By using a keyword called typedef, we create a simpler nickname for it. Now we can just use student like it was a built-in type. Like int or float. It makes things so much tidier.
So, we've done a great job organizing our student data in memory. That's awesome. But, there's a pretty big catch. The second our program closes, all that information, poof, it's gone. To make it stick around, we have to save it to a file. This is one of those fundamental truths in programming. All the variables and structs you make, they live in your computer's RAM, which is temporary or volatile memory. That means when the power goes out, so does your data. If you want to save that information for later, you have to write it somewhere permanent, like your hard drive.
Working with files in C always follows these 3 basic steps. It's a cycle. You open a file, which gives you a special pointer to it. Then you do your thing. You either write data to it or read data from it. And finally, and this is really important, you close the file to tell the operating system you're all done with it.
So when you open a file using the open function, you have to tell it what you want to do. We call this the mode. So R is for reading, W is for writing, but be super careful with this one because it will completely erase the file if it's already there. And A is for appending, which just tacks your new data onto the very end of the file.
So here's how we actually write our students' info to a file. We use FOPN to either create or open a file called students.txt in write mode. Then we use fprintf. Now this function is going to look really familiar because it works almost exactly like printf, but the first thing you give it is that file pointer. It just writes our nicely formatted student data right into the text file.
And getting that data back out, well, it's just the reverse. We open the same file, but this time in read mode, which is R. Then we use fscan.
It reads the data from the file and neatly fills in the members of a new struct variable. It's really important to remember that for things like integers and floats, you need to pass the memory address of the variable, which is why we're using that little ampersand symbol, like andstudent2.id.
Whew, we've actually covered a ton of ground pretty fast, right? We went all the way from creating our own custom data packages to actually making them permanent. So let's do a quick flyby of the key tools we've just added to our C programming toolbox.
Okay, let's nail this down. Struct. It lets you create your own data types. The dot operator, that's how you get inside them. Typedef makes your code so much cleaner. Then you have your file functions, fopen, fprintf, fscanf, and please remember the all-important fclose. Seriously, getting these concepts down is a massive step towards building some really cool, powerful applications.
So, what does all this really unlock for you? Well, with structs as your foundation, you can start building almost anything. Think about it: an inventory system for a video game, a way to manage patient records for a hospital, or even handling complex data from a physics simulation. All of these advanced applications rely on this simple, yet incredibly powerful idea of grouping data together. Thanks so much for watching.